Hello everyone, I'm Dr. Nitish. Welcome to Intuition. Today it is the Michelson-Morley Experiment, or MMX, called the most notable failed experiment of all time. But we will see how actually it is the most successful one. It wasn't intuitive to me for a long time because many sources don't show the correct calculation. Not even the great Richard Feynman. Yes, but we will find the correct one, and we will marvel at the enormous impact it had at the physics of its time. Let's into it. Einstein said that he did not consider the MMX when developing relativity. But in 1940, when he looked back at the importance of this experiment, he wrote this: "If the Michelson-Morley experiment had not brought us into serious embarrassment, no one would have regarded the relativity theory as a half redemption." Maxwell's equations were enough to develop the complete relativity theory, but they had it hidden in them. Enough to make physicists uneasy, but not enough to make them scurry around in its search. MMX exposed the issue strikingly, demanding immediate attention, and made physicists ready to accept a radical change. Maxwell in 1862 showed the world that light is a wave, with a speed that he calculated, not measured, calculated. We shall come to that when we discuss electromagnetism. Anyhow, if light is a wave, it needs a medium to travel. This medium, called Aether, had to be present in the entire cosmos since light travels across space from stars to us. And you see, Galilean relativity had established that motion is only relative to other matter, not to empty space. And Newton had defined space to have no effect on matter. You can see more of this in this video. So, nobody had tried to detect absolute motion relative to a fixed universal background. But now there was something. This ether, relative to which motion could be perceived. Enters Albert Abraham Michelson, a brilliant experimenter who had developed the interferometer and measured the speed of light to high accuracy. He considered it his duty to detect the existence of the ether. He tried alone in 1881, but didn't detect it. So he collaborated with the noted chemist Edward Morley, refined his apparatus, and tried again in 1887 in the basement of a university building in Cleveland. The experiment setup was quite elaborate and sophisticated, but we require just the schematics here. What we need are two light rays of the same wavelength, in phase, perpendicular to each other, and two mirrors equidistant from the light source which reflect the light back, where these two rays combine to show an interference pattern. This is the essence of the experiment. Because two light sources with exactly the same wavelength are tough to make, a single source and a half-silvered mirror were used. The source emits a beam of light, some of which gets reflected at this half-silvered mirror and some passes through. Then they get reflected at this full-silvered mirrors. To meet that half-silvered mirror again, some of this light passes through and some of this gets reflected to finally meet this screen. There were a lot of extra bells and whistles and exact measurements to make the experiment capable of not just detecting, but measuring the speed of the ether wind. Now they needed to move the apparatus relative to the ether. But that was already taken care of. We are all moving with the earth through the universe at a speed much faster than any man-made thing. They could just use that. Let the speed of light be c and the speed of earth be v. Now suppose that one of the path coincides with the direction of earth's motion through the ether. An apparent ether wind will be flowing opposite to the direction of light on this way and along the direction of light on the way back. Oh yes, this will happen as the light is at speed relative to this ether and the ether is moving at v relative to the apparatus. So on this way, the speed of light is c minus v, and on the way back, it is c plus v. Now, mind you, the equation is not L plus Vt by c, as some sources say, but L by c minus v. It is not about the earth covering more distance, but the speed of light getting reduced and the speed of light getting increased by the same amount on the way back. So what is the total time taken for the return trip? It is L by C plus V plus L by C minus V, which is equal to LC minus LV plus LC plus LV by C plus V into C minus V. This reduces to 2LC by C square minus V square. Dividing the numerator and denominator by C square gives us 2L by C by 1 minus V square by C square. Let's look at the other arm now. This light ray is going perpendicular to the first one. So it must be moving at 90 degrees to the ether flow. This is again where most sources show a miscalculation. They assume, again, that the distance that light has to cover increases due to the Earth's motion through space. They show an increase in the track length, but no increase in the speed of light. It is actually correct in a way. The speed of light really doesn't change. But that constancy of C was the surprising result of this experiment. It cannot be assumed and used in the calculations. The correct way is to think that the ether wind pushes the light ray, changing its direction. We have to assume the light ray to be angled such that the ether wind pushes it back to the perpendicular. Even though Michelson and Morley did not design it like that. This is like a swimmer crossing a river and returning back to his original position. He must have directed his efforts at an angle to the river flow. So this velocity is C and this is V. The effective up-down velocity is under root C square minus V square. And the time taken for the round trip of 2L is 2L by under root C square minus V square. Dividing the numerator and denominator by C gives us 2L by C divided by under root 1 minus V square by C square. Now when you compare these two expressions, it shows that the numerators are the same. The denominator of the perpendicular arm is the square root of the parallel arm. And because this number is less than 1, it is 1 minus something, the square root of this is larger than this. So this number is smaller. Thus, going parallel to the ether wind takes more time than going perpendicular to it. So the light on the parallel arm should have reached later than the perpendicular arm. And this difference in travel time would cause a phase difference and interference at this screen. So this difference in travel time was to be measured. Since L, the length of the arms was known, and C was known, the speed V of the ether relative to Earth could be calculated. What did they find? No time difference at all. Zero. Zilch. Nada. Shunya. The ether is not moving at all with respect to the Earth. This is a very big finding. One that defies all logic. And see, this is a logical problem, deeper than a scientific one. If you move relative to a medium, you also move relative to the wave in the medium. Here you are definitely moving relative to the medium, but not relative to the wave. This is logically inconsistent. Look, this is not an issue at all if you are dealing with a non-wave entity, like a ball. Throwing two balls at right angles and bouncing them back will not show any difference in time. If light were not a wave, then there was no strange thing happening here. Light could be just tiny balls bouncing around, requiring no medium. Simple. Newton had a corpuscular theory which dominated the 17th and 18th century. But a lot of compelling evidence had accumulated that light was indeed a wave. And actually that was the reason why they were doing this experiment in the first place. Michelson-Morley kept repeating their experiment in different orientations, different times of the year. But the finer their apparatus, the closer they reached to zero. The only reasonable way to make any sense was to posit that ether does not move relative to Earth. Maybe the Earth drags the ether with it. The weight carries the atmosphere with it. But there was strong evidence against this hypothesis. Actually, it could also be explained if the ether was moving at 45 degrees to the arms. But they repeated this experiment many times. With the whole apparatus rotated, still no difference. Let's go a little deeper into the experiment now. The goal was to measure the absolute speed of the apparatus through ether. But what was getting measured was the ether wind. Or was it? Not even that. Was it the change in the speed of light? Not even that. It was the difference in the number of wavelengths. Yes, that is what it was eventually measuring. The change in the number of waves on rotating the apparatus. It was repeated by Michelson many times afterwards, with more accuracy, but the result was the same. Null. It wasn't about measuring the speed of the ether wind anymore. It was just about detecting any change. He no longer needed the two rays to be perpendicular, or of the same wavelength, or even in phase. He didn't even need the tracks to be of the same length. The experiment had to just show a change in the interference pattern on rotating the apparatus. A null result is very different from even a very tiny difference in this case. Michelson was heartbroken. He couldn't believe the null result. He kept on repeating this experiment for decades with more and more refined apparatus. But as incredible it may be, the null result was not completely unexpected for other physicists. They already started explaining it. Fitzgerald tried to explain this in 1889 by proposing the contraction of the parallel arm of the apparatus, a curious phenomenon which was laughed at by his peers. But when the great Lorentz developed it, the physics community had to agree. And then Henri Poincaré developed it even more, naming these equations as the Lorentz transformations. We will cover these transformations in detail in our next video. Would there be a relativity theory without the MMX? Yes. But it would have taken many more years. It's called the most famous failed experiment. Let's talk about that. What was this experiment designed to measure? The effect of the ether wind on the speed of light. Now, how much is that effect according to our current theories? 0. And what value did MMX get? 0. It got the exact value. Yes, within the acceptable margins of error. This is like an X-ray that shows there is no fracture where there is none. As a doctor, I will consider that to be a very accurate result. And so what was its impact on physics? When this guy in 1905 wrote a paper suggesting the absence of ether altogether, people agreed. Can you imagine how ridiculous that proposition was? Light is a wave without a medium. Lorentz, Poincaré, Michelson himself couldn't accept that, but they too couldn't argue against it. Such was the power of MMX. And this is the beauty of science. Experiment is the king. Everything else has to be sacrificed to save it. Subscribe, share, like, and join us in the next video about what happened next. We are laying the foundation of an intuitive understanding of relativity and eventually the twin paradox and time travel. Take care.